In this video, we're going to be taking a look at the hydrolysis involving a strong base. This is a type of substitution reaction. We get a different type of hydrolysis, and that is the one involving water. But before I start to explain the hydrolysis involving a strong base, I just like to make a few corrections to your textbook. So wherever you find this, I'm not too sure which page it is on, you're going to see under reactants, they say alcohol. This is actually a haloalkane. Please go and fix that. It's going to react with dilute strong base. And in the end, we're going to have an alcohol as the product and salt. Here in the general reaction equation as well, this is not an alcohol, it's a haloalkane. On the right, as a product, we have an alcohol, and this is not a hydrogen halide, it's going to be salt, not necessarily table salt, any type of salt. Now, with the hydrolysis involving water, where they write method 2, there are mistakes as well. So they were correct to say here it's a haloalkane, and then an alcohol is going to form. But if you go on to the right, where we have the general equation, this needs to be replaced with haloalkane, and this haloalkane needs to be replaced by alcohol. So please, when make those corrections, don't leave it, or you're going to be very, very confused. If you don't trust this textbook, if you feel like there are just too many mistakes in it and you don't want to use the theory in these textbooks, you're more than welcome to make use of your answer series textbook and then just use these textbooks for the problems. All right, so on to hydrolysis involving a strong base. What is going to happen here is we're going to start off with a haloalkane, and we want to convert it into an alcohol. We're going to do so by reacting our haloalkane with a dilute, so aqueous solutions of strong bases like sodium hydroxide, potassium hydroxide, and lithium hydroxide. Remember, the word strong and concentrated do not mean the same thing. So I explained this in previous videos. I'm not going to explain them again. Just remember, the opposite of strong would be weak, while the opposite of concentrated is dilute. And here we have a dilute. So if they say aqueous solution, it's a dilute solution of a strong base, okay, which means we have few particles of the strong base, and we say it's strong because it dissociates completely when placed in water. Then what is going to happen is that the OH group from our strong base is going to replace a halogen atom in the haloalkane and convert it into an alcohol. This is going to make a bit more sense when I actually show you the reaction equations. Now, what's important for this reaction is, well, the conditions. Number one, we need a diluted strong base like sodium hydroxide, potassium hydroxide, or lithium hydroxide. And then this is going to be performed in the presence of heat. So they say dissolve the haloalkane in ethanol. You don't need to know that off by heart, but very important, this reaction will take place in the presence of heat. Now, it's very important that you make use of a dilute. Is that how you spell dilute? Perhaps I spelled it wrong. My apologies. Okay, I don't know if it's double L or one L. Oh, it's one L. Okay, so dilute like this. Okay, so over here they say the reason why you need to make use of dilute strong base is because if you use a concentrated strong base, you're going to perform an elimination reaction instead of a substitution reaction. So at this point, somewhere, write this down. If we have an elimination reaction, the strong base is going to be concentrated. On the other hand, if we are performing a substitution reaction, the strong base is going to be dilute. Okay, so dilute is substitution, elimination is concentrated. We need it to be concentrated. We need a lot of these molecules in order for it to completely eliminate what we are removing. Where substitution, we're just performing a replacement. Okay, so moving down, here we have a few examples of hydrolysis involving a strong base. We have 2-chloropropane. This is an alkane, and it is going to react not with potassium hydroxide here, but sodium hydroxide in the presence of heat. When this reaction takes place, the chlorine atom, which is our halogen, is going to break off from the carbon. The sodium hydroxide, the OH from the sodium hydroxide, which is actually already dissociated. So we have sodium positive ions and OH negative ions floating in water. This here is going to covalently bond here onto our carbon where our chlorine used to be. And then we are going to have an alcohol forming and sodium chloride. So here at the end you can see we have propan-2-ol, that's the alcohol that is formed, and sodium chloride is the salt, the byproduct of this reaction. This is a hydrolysis reaction. It's a substitution reaction because we have a saturated compound reacting to form a saturated compound, and that means it's a substitution reaction, the triple S. Here we have another example. So they say we have 2-bromo, 2-methyl propane. This is actually a tertiary haloalkane because the carbon onto which our bromine atom is attached is bonded to 3 other carbons. But there is no specific reaction conditions for primary, secondary, and tertiary haloalkanes as far as I know. So this is going to react with potassium hydroxide, where our potassium hydroxide is going to be dilute and it's a strong base. Our bromine atom is going to detach and it's going to change places with the hydroxide ion, so that here we have an OH bonding instead, and here we have bromine. In the end, we have the formation of an alcohol and potassium bromide, which is our salt. And this again is a substitution reaction, specifically hydrolysis, involving a strong base, because we start off with something saturated and end off with something saturated as well. In the next video, I'll explain the last type of reaction in organic chemistry that we study, and that is the hydrolysis substitution reaction involving water.